Hey y'all, welcome back to chemistry class. Today we are going to be talking about nomenclature, which is another fancy word for naming compounds. So our first thing we always have to think about with nomenclature is if something is ionic or covalent. So if you see a formula of any kind and you're asked to name the formula, you need to decide, is this ionic or is it covalent? So we have our periodic table of elements, and just to recap or review, we remember an ionic compound is when you have a metal with a nonmetal. So again, right here, our metalloids are going to separate the metals from the nonmetals, and we have our metals over this side and our nonmetals over here. So an ionic compound is when you have a metal with a nonmetal. Covalent is when you have two nonmetals, so two of these small groups over here. Two of them bonded together is a covalent bond, and ionic is when you have a metal with a nonmetal. So with nomenclature, there are actually 4 styles of naming. So first you decide, is it ionic or covalent? If it's ionic, the first type we're going to talk about is the simple ionic compound. So a simple ionic compound is going to have a metal from over here, or maybe even right here, and then it's going to be with a nonmetal. So we are not including these metals, okay? So it's an ionic compound with one of these sort of normal metals with a nonmetal. Transition metals will not be included. With a simple ionic compound, like we just said, it includes a metal from groups 1, 2, or 3, with a nonmetal. So this is group 1, this is group 2, this is group 3. You might occasionally see another one of these, but that's fairly rare. An example of this would be NaF. So we have Na right here, F over here. So we have sodium and fluorine. Alright, so we have a group 1 metal with a nonmetal. And what we're going to do is it needs to be named using this convention down here. So we take the metal name, and we just write that fully out. So with sodium, the full metal name is sodium, so we write sodium. The second part of it needs to be the root of the nonmetal, so take off the ending, just the root of that, and add IDE at the end. So sodium fluoride. So it started as fluorine. We took off that ending, the ene ending, and put ide. Finished it with IDE. Here, let's do a few more examples. Okay, so let's take a few more examples. We'll take a group 1, a group 2, and a group 3, just so that you can see that they vary. So potassium is in group 1, so we can do K, and then a nonmetal, S. Okay, so this is, remember K has a +1, S has a -2. We need to crisscross those. So it's K to S. That's going to be your full formula. And now let's name this using this elementide. So again, it's going to be elementide. Okay, don't forget about that IDE. So, we have to take the first element, right? We don't care about the numbers, we're just looking at the element symbols. K is potassium, so that's going to be potassium. And then we have sulfur, right? Sulfur, so we take off that ending, sulf. So sulf, and then we add IDE at the end. Sulfide. So potassium sulfide. looking at another example, we can do group 2. Let's do BA. Okay, so we'll take BA, and BA has a +2. Okay, so +2, and we can look at N. Okay, and N is in this column that has -3 charge. As for these charges, I'm showing you this because this is how formulas are made and this is how elements bond. I'm very aware that you may have pretty limited knowledge on this because of the gap between Miss Doherty and I, so just be patient and just watch what I do. So again, I'm going to crisscross these numbers, not the plus or minus, just the numbers, and we're going to get BA3N2, and that's going to be my full compound. Okay, so now with that full compound, I need to write what that name is going to be. Okay, so I do element I, so I'm going to name this first one. That's going to be barium. Okay, and then I have to take nitrogen, but then the root, nit, so I took the gen off, so nitrogen, the root of that is just nit. Nitride. Okay, so barium nitride would be the name of this one. And let's do one more. I'm going to erase this top one. Okay, looking again at this top one. If I give you something from group 3, let's say aluminum, okay? Aluminum has a charge of +3. Then we can take another one, oxygen, maybe. Oxygen has a charge of -2. So we crisscross those, and we get Al2O3. Okay, so that's how I get that first part, and now I need to name it, element I. So we name our first element, aluminum. And then we name the root of oxygen, so ox. So we take away the ending, we just leave ourselves with ox, and add IDE at the end, oxide. So this compound is aluminum oxide. Okay, I'm going to give you guys a couple to practice on your own. Okay. I want you to do MgO. I want you to do CaCl2. I'm just doing these with the crisscross because I know how to do them already. If you want additional help on writing formulas, we'll get to that later this week. Okay. And then let's do boron with chlorine. No, we already did chlorine. Boron with sulfur. Alright guys, pause the video, work on doing these 3 problems, please. Yep. Okay, pause it. Okay. Hopefully you paused the video and you're looking back at this. I'm going to name them for you. So element I, this should be magnesium oxide. This one, element I, calcium chloride. And then this one, boron sulfide. Okay, now this one may have been a little tricky because it sort of feels like it's not ionic. It almost feels like it's covalent, but remember, everything to the left of this is going to be a metal. So that staircase, in case you need to know where it is. That's going to be right here. Okay, so hopefully that helps you. So that's it for our simple ionic. I'm going to show you one more ionic compound today, and then later next week we'll do the third ionic type of compound, and we'll do the covalent compounds. Alright guys, take care.